hopefully you can hear me. John, who's here in the room, he has just verified that we're producing audio. Welcome to Microsoft Ireland, because that's where we are today. We've just been at a Microsoft partner event in the European Operations Centre. Actually, we're not even in the European Operations Centre. We're in a building full of Microsoft developers and program managers, all the people producing things like Windows and Azure and stuff like that. So we're surrounded by lots of secrets and locked doors, kind of cool, and we've lots of lovely food in front of us as well. So if you hear me chewing, sorry, I'm hungry. So my name is Aidan Finn. I'm the technical sales lead at MicroWarehouse, and I'm the person responsible for presenting these webinars, and alongside me is John Moran, who produces and good stuff. And a shout out to Glenn, who makes it all look pretty before it goes online when it's YouTubed and all that lark. Oh, John's taking credit for that too. So I'm a Microsoft MVP at the Cloud and Data Center, or Hyper-V expertise. I a lot of background in Hyper-V and System Center and desktop management and Azure and all that good stuff. And my job is to learn about this stuff and then evangelize it to our customers who are Microsoft partners in Ireland and Northern Ireland. I blog on aidanfinn.com, and I'm the contributing editor on Microsoft Virtualization for Petri.com. So a lot of stuff that I talk about you'll find on those sites. I tweet as @Joe_Elway, and I also can be found on aidanfinn.com on Facebook. MicroWarehouse is a distributor focusing on technology. That basically means we're a wholesaler, so we sell to the people who sell to the customer. And brands we deal with are companies like Microsoft. We are a Microsoft Tier 2 CSP provider, so if you want to resell Office 365 or Azure or any of those cool things, we do that. And apparently my screen is not shared. It should be. Oh, my screen is now shared. Sorry about that. I was kind of hoping that I might have heard that a little earlier. And the thing said the screen was shared. Damn, no intro music. So we deal with the likes of Microsoft, Data On, Skycake, and stuff like that. And if you want to learn more about MicroWarehouse, you can find it on www.mwh.ie and at MWH Distribution on Twitter. So what are we going to talk about today? We are going to talk about Windows Server 2016, and we're going to focus on the stuff produced by the High Availability and Storage team. So we're talking about failover clustering, storage replica, storage spaces direct. Then we're going to look at how you can troubleshoot those things, and then we'll talk a little bit about some events and training that we've got coming up afterwards. Now, I showed this slide last month in the Hyper-V webinar, and if you go to learn.mwh.ie, you'll actually find a link to our Hyper-V webinar up there. So we have that recorded and download notes and all that sort of thing. Windows Server 2016 is very much inspired by the cloud. So whether it's you want to produce your own cloud for internal or external consumption, or you are talking about features that came from Azure, Windows Server 2016 drew a lot from those themes. Microsoft wanted to make things easier, and they wanted to improve service availability. And you'll see a lot of service availability in this presentation, because obviously we're talking about failover clustering and storage, which needs to be highly available as well. A lot of your feedback has shaped Windows Server 2016 as well. So we're nearly at 2 years of technical previews for this build. It's going to get launched next Monday at Ignite in Atlanta. So that's nearly 2 years of feedback shaping 5 technical preview releases. The product has changed a lot since TP1 to what we have in TP5, and I'm sure there'll be a few surprises when it goes to GA whenever that is. So there's a lot in there. If you've tested and supplied feedback, you have helped make this product, and you can continue to do so at windowserver.uservoice.com. So let's start talking about HA, or failover clustering. First thing I want to talk about is, well, we're going to talk about Hyper-V, because, well, I'm a Hyper-V guy. We now have true VM start ordering. We did have something in 2012 and 2012 called VM priority, which some of us used as a way to do start ordering in a failover scenario, but that's not really what it was intended for. It was more intended for prioritizing resources when we were doing a failover and we had contention of resources. VM start ordering is about, hey, I'm starting up my cluster and I need to make sure that the different tiers of my application or dependencies between applications start up in the right order. So simple example is I want to get my domain controllers online, then my database servers, then my application servers, and then my web servers, because one can't start before the other. Obviously, it's pointless starting up my SQL servers before my domain controllers if I'm using Windows authentication. If my application servers require a database, what's the point in starting them up before my database servers? So we can group these various different virtual machines into sets, and then we can create dependencies between those sets. So we might say, okay, set 2, which is database servers, depends on set 1, which is domain controllers. Now, how do we know if the domain controller is online? Well, we might say, well, the virtual machine has started. Now, I personally don't think that's a very good test, because that just means that the machine managed to complete its post. So that's the little 2 seconds delay before the OS starts booting. That's not much of a test to see if the virtual machine is actually running. You could do a delay or a wait. So we might say, wait 60 seconds because my domain controllers will be online then. Are you sure? Are you sure they didn't blue screen on the startup? Are you sure the services have actually started? Because if you're starting your PDC emulator for the first time and it's the first presence of your domain, that thing can take a little bit of time before it actually really starts kicking off. Or you could say, wait for the integration component heartbeat to start responding to the host. So there's a regular heartbeat that goes on between the hosts and an integration component called a heartbeat inside of the guest OS of the virtual machine. When that starts responding, well, the operating system is up and running. Services have started. Now, it is not an application layer dependency. We're not able to say that SQL Server has started and was responding, or DNS has started and responding. I think that's something Microsoft would like to do in the future. And if you want to hear about that, if you want to see that, go to Windows User Voice and submit your feedback to say that you would like to see that. The other thing we can say is we can define the success of a set. So if we have a set of 2 database servers that are running as a cluster, do we need both of them running to say that the database is operational? Maybe we say that one of the 2 machines is running. And then we have a successful database, and now we can start powering up application servers that rely on that database. We can also trigger dependencies on external sets, so we don't have to have an intrinsic dependency. We can have an external dependency as well. This allows you to do some pretty complicated modeling of your applications and your virtual machine dependencies and application dependencies. I briefly talked about storage resiliency in the Hyper-V webinar last month as well, but it's a feature of failover clustering that we should talk about. Most infrastructure problems that we encounter are transient, and I'm going to be saying that again in the next slide, because it was a related feature we need to talk about there. If we're talking about storage, a common glitch is that the network may have an issue. It might last a few seconds. Now that few seconds can be enough to freeze the I/O of a virtual machine. So the virtual machine is trying to do a write or a read to its storage, and it's not able to. It times out, and the operating system in the guest OS has no choice but to crash. So you get your blue screen of death, or your sad face of death screen, or you get your bug check in Linux, or whatever it is. And then you have to start up the virtual machine when the storage comes back online. The storage may actually come back online after a few seconds. And then you have to go back and start all your virtual machines up in the right order. Hopefully you've done your dependency modeling. And then you have to wait for the services to start up. So it could take several minutes. So that's a lot of downtime to the business just because your storage network had a glitch. Windows Server 2016 takes an interesting view of the world. Crap happens. Sometimes these transient errors come along and we just have to deal with them. So instead of just panicking and throwing our toys out of the pram, we're just going to say, you know what, if storage I/O freezes or stops, we're going to place that virtual machine into a pause critical state. So this means that when the storage comes back online a few seconds later, the virtual machine is in a pause state where the application state, which is important, is retained. Now the virtual machine can be unpaused, restarted, and it continues where it was. So it's just like hitting pause on a Hyper-V virtual machine and then starting the virtual machine all over again. So we did have a few seconds of outage because the storage had a glitch, but once the glitch was over with, the virtual machine was back and offering services to the network and to the business again, which means we minimized the issue that was caused by those SAN engineers, because we always know all problems are caused by SAN engineers. Or they may be caused by network engineers, which can lead us to compute resiliency. A failover cluster is dependent on the networks between the nodes, and sometimes those networks can have glitches. And those glitches, again, can be transient and only last a few seconds. Now, if we have a 10-second glitch, because a heartbeat happens every second, and if we've missed 10 of those heartbeats, a node is assumed to be offline. And that's the way it is in 2012 or 2. If we have that happen, well, the cluster just assumes that node is offline and initiates a failover, which means virtual machines fail over to other nodes and have to be started, and the services that are in those nodes or in those virtual machines have to start up. So we could lose several minutes because of a few seconds, maybe 11 seconds of a network glitch. Maybe an operator pulled the wrong cable out of the back of a server or the back of a switch or something like that. Windows Server 2016 goes down another route and says, you know what, crap happens. We're not going to actually initiate a failover of the virtual machines if those things are still on the network offering services to the business. Because we do have other mechanisms that are in 2016 to move virtual machines if their network is disconnected. If those virtual machines are still on the network and still offering services on that host that's assumed to be isolated, we're going to leave those virtual machines there. Because the hosts, well, we don't really care. It's the virtual machines that are important. If the host comes back online, great, it rejoins the cluster. If we see the host constantly having issues, so I believe the default is 3 issues in 1 hour, then the host will be quarantined automatically for 2 hours. That's the default. And then the cluster will live migrate the virtual machines off of that host to healthy hosts. And then operators or engineers have the opportunity to take that 2 hours and troubleshoot what's wrong with the host. Maybe they need to evict it and replace it. Maybe they need to rebuild the OS. Maybe they need to set it on fire or put it in a replacement. But they have that opportunity to do that with minimal downtime to users in the business. The title of this slide is wrong. It should actually talk about node fairness. In the past, we have not had automatic load balancing of virtual machines in Hyper-V. If we wanted that, we had to do dynamic optimization in System Center. Now that was unfortunate because a lot of customers, and I heard Microsoft saying publicly that they reckon about 50% of Hyper-V customers don't use System Center. And of those System Center customers, I'd say it's even a smaller percentage who use System Center Virtual Machine Manager, which offers dynamic optimization. Which means a very large percentage of customers don't have automatic load balancing of virtual machines. So if one host is overloaded, whether it's RAM or processor, it remains that way unless someone manually moves virtual machines to another node. In 2016, we get node fairness. And this is a mechanism where we can move virtual machines based on CPU or RAM utilization to other nodes. So we can spread the virtual machine load across the entire cluster. The evaluation is done in 2 scenarios. When a new node joins a cluster, and I shouldn't actually say new because it could be a node rejoining the cluster, and it happens every 30 minutes. And everything about this is configurable. There are 3 levels of aggressiveness. The default is low. So when a host reaches 80% utilization of CPU or of RAM, it can trigger an evaluation. And that will result in virtual machines live migrating. And I should say that node fairness will only live migrate a few virtual machines at a time. So if you do have a single node that has a high number of virtual machines and another node that has no virtual machines, you won't see that instantly even out straight away. And the phrase I heard Alden Christensen use in a webinar with Carson Rackfall recently is that it's kind of a sandpaper approach. They'll sand it every now and then and even out the bump. So over time, they'll live migrate virtual machines across the network because they don't want to saturate that live migration network with virtual machines. The medium setting is when we have 70% utilization of CPU or RAM. And the high setting is when any host is 5% higher than the average. So if we see one host being at 35% utilization and all the other hosts are around 30% utilization, then that will trigger an evaluation and a live migration of a few virtual machines to balance it out. Microsoft have supported stretch clustering since, I believe, Windows Server 2000 or Windows 2000 Server. But I've always had a problem with stretch or multi-site clustering. A lot of people viewed it as a way of doing disaster recovery. To say, I have some nodes in site A and some nodes in site B, and if one site burns down, that's great. My virtual machines will fail over to the other site, and my business will stay up and running. And in theory, that was great, but my problem was that clustering did not understand that there was a difference between these two sites. It just viewed it as one flat cluster. Even if it had two different storage systems that were replicating, it viewed it as one flat cluster. So you could see things like live migration happening across that cluster and failover happening across that cluster when there wasn't actually a disaster. So you could end up with virtual machines in the remote site being used by local users in this site. And it ended up with a lot of inefficiencies. And there were ways and means to try to prevent that, but it was trying to reinvent the wheel with a square, and it just didn't work too well. So what we get in, and I was on the wrong side, what we get in Windows Server 2016 is site awareness. And this is where we can truly use clustering as a DR solution. So we're able to make hosts aware that they are in different sites. So we can have a production site and a disaster recovery site. We can have site A and site B. And we can make sure that placement of virtual machines stays within the site. So if I do have a production site and a node goes offline, failover will stay within that site. It won't happen accidentally over to the other site as it would today in 2012 or 2. And when we do node fairness or load balancing, that will also stay within the site too. It's important that Microsoft makes sure that virtual machines follow CSV ownership, and they do that. So if CSV ownership moves to the other site, the virtual machines that are stored on that CSV will follow that CSV ownership via live migration. Now when we're doing stretch clustering, one of the things we needed to do in the past is have a third physical location, which if you've only 2 sites is kind of difficult. And even if you do have multiple sites, you may not have computer rooms or data centers in that third site. So we needed a third site, and we need to have something called a file share witness. Now preferably that file share witness was on a cluster because we needed it to be highly available. Preferably, but it could just be a normal share on a single file server. And if you are putting a cluster in there, you may say you want that highly available, and we could end up with one of those Russian doll scenarios where we need a DR site for a DR site for a DR site for a DR site. So we needed a third location and a file share witness, and that could get expensive. And Microsoft for years wanted to solve this, and Azure has given them the opportunity. We can provision a storage account in Azure and use that as a cloud witness. Now you may wonder, okay, Microsoft want me to use a storage account in Azure. How much is that thing going to cost me? Well, the good news is all that stores is a simple sequential number, a number that increases every now and then. So the nodes, when they're trying to calculate quorum, are just increasing that number. So it's just a digit. So the thing doesn't cost money. In fact, Microsoft have said that when they've been doing testing, no one's actually incurred enough of a charge to round it up to 1 cent for that month. So the thing is cheap. And in terms of valuable data, all it has is a sequence number. So if you're worried about the US government spying on your servers, all that's in there is a number. So the number 4 is not very valuable secret. So you don't have to worry about that sort of thing. An interesting change or of evolution that we've seen in clustering in 2016 is the ability to support a cluster that's either got all its nodes in a work group, or where some nodes are a member of one domain and the other nodes are a member of another domain. So this is mixed domain or no domain membership. This is not something we've been able to do in the past. In the past, all our nodes had to be a member of the same domain because all the communications within the cluster are domain authenticated. Now we have this new ability. It's primarily intended for SQL clusters and allows them to do very interesting things in terms of DMZs and multi-site resiliency. We can use it in Hyper-V. So you can have a Hyper-V cluster that is not a member of an Active Directory domain, and that might be useful in a DMZ type environment. But what you have to know is you lose live migration. Live migration requires Kerberos authentication, and in the Windows world, we get Kerberos from Active Directory. Do I think we will reach a point in the future where we could do this? I would love to think we could. I would love to say that we could build a Hyper-V cluster with live migration with no Active Directory, because that really would simplify and scale out how we build environments. But it's not there yet, so watch out when you do see mixed domain or no domain cluster support, because it really is intended for SQL clusters at this time, although we can use it with Hyper-V, but with no live migration. Another nice interesting change, and it's a subtle thing in clustering, is in the area of SMB networking. So if you were building a scale-out file server, you're using a protocol called SMB to connect your Hyper-V hosts to that scale-out file server. So they store their virtual machines on a file share. SMB is capable of aggregating NICs and doing LBFO, or load balancing and failover, across multiple NICs. So if I have two 10 gig NICs, I don't have to team them. SMB multi-channel sees those two 10 gig NICs, sees that they have a connection to my remote file server, and will aggregate that bandwidth together. And if one of those NICs fails, it just goes, no problem, I'll continue to use one NIC. So I can get myself 20 gigabits per second instead of 10, or 80 gigabits per second instead of 40, or 200 gigabits per second instead of 100, depending on what type of NICs you're using, which is great. However, failover clustering requires that both of those NICs be on two different subnets or VLANs, so two different network addresses. Now, SMB channel didn't require that, or SMB multi-channel didn't require that, but failover clustering did. That changes in Windows Server 2016. So we can have both of those storage NICs in the same subnet or VLAN. So that simplifies the configuration side of things, simplifies the network addressing, but importantly, reduces the amount of VLAN provisioning that we have to do. So if you're in a very large environment, this is very good news for you. Less VLANs makes the network guys really, really happy. Right, let's do a little bit of advertising. So we have to pay for these webinars somehow. One of the brands that MicroWarehouse distributes to resellers is a company called Skykick. Now you can buy services from Skykick directly, but if you are a Microsoft partner, it is actually more cost effective to buy it through distribution, and Skykick will tell you that too. So the first service that Skykick offers is the ability to migrate to Office 365. So if you want to migrate from syndicated Office 365 to CSP 365, you can do that. Or if you want to migrate your Google Apps or your Exchange to Office 365, you can do that. Long term, what they want to do is solve a problem in Office 365. Dirty little secret, it doesn't have backup. Office 365 has recycle bins. So if you delete a mail or a document in your OneDrive, might be there for X number of days, but then when you release it, realize that you lost it 100 days later, well, there's no way of getting that back. This is where we bring in Skykick Backup. So we can back up Office 365, your Exchange Online, your SharePoint, your OneDrive for Business, all backed up actually to an Azure storage account, either to your own subscription or to free capacity that you get with your per user licensing for Skykick Backup. So that's an interesting product to look out for. If you're interested, hey, contact MicroWarehouse and we'll try hook you up. If you're a Microsoft partner, you actually get it for free, so have a look at it for your own internal usage. So let's talk about another cool solution from Microsoft in 2016, which is Storage Replica. Disaster recovery is definitely a challenge for businesses out there. Whether they're small or big, they're all struggling with it. And Microsoft witnessed, especially during some of the hurricanes that have happened in the US in the last few years, that a lot of enterprises, organizations with multiple sites and storage area networks or SANs, are really struggling with disaster recovery, which was a bit of a puzzle. When they went out and started talking to these companies after the disaster, when they had serious downtime, what they found was that these guys didn't implement SAN level replication because very often they found it to be too complicated or too expensive. They just couldn't afford the licensing. Now, some SAN vendors, they just build it in there, or they just charge a few €1,000s. Some of the guys out there charge a lot of money for replication. So it can be very, very expensive. So you get roped in by the nice sale about buying this lovely, sexy SAN, and then you go to do DR afterwards, and that's when the sales guy drives up in his Ferrari that he's bought based on the licensing you're about to buy from him. So these guys really struggled, and Microsoft wanted to help these guys by implementing storage replication at the software layer. You heard it, block level replication built into Windows Server 2016. Now this is implemented low down in the storage stack, which means it doesn't care about the upper level things like dedupe, thin provisioning, BitLocker, NTFS, ORFS, SMB, or VSS. It just doesn't care. It just replicates blocks that are down at the low down physical volume level. It doesn't care either what you're replicating between, as long as it's cluster supported. So you can replicate between two identical SANs. You can replicate between two different SANs. You can replicate between two implementations of storage spaces. Maybe one's running on data on, the other's running on Dell, because you want to put the Dell stuff in the DR side. You're not that worried about the performance. Or, hey, you can also replicate between storage spaces and SAN and vice versa. So this is a really cool solution that's vendor agnostic. Like I said, it's block level and it replicates volumes. Good news is it only replicates provisioned blocks. So if your storage system has thin provisioning, this thing's going to do it very effectively because it's only replicating those blocks that have been provisioned. And the other 0 blocks just aren't replicated because what's the point? They're zeros. It does synchronous replication. So if you want 0 data loss, you can get it. Now you got to remember synchronous replication does have an impact on storage latency. The more latency you have between the two sites, the bigger impact you're going to have on storage latency dependent applications like SQL Server and Oracle and all that stuff. Microsoft reckoned that the maximum latency you should have between the two sites is 5 milliseconds. And based on what I've been digging around looking for in terms of distances, the max that I can see is about 80 kilometers. So have a look at what Mellanox have provided with InfiniBand and a switching system or a networking system called MetroX, which supports links of up to 80 kilometers. And we also have asynchronous replication. So if you want to have much longer distances between your sites where you do have a latent link, you need to go asynchronous replication, and that's where you have periodic replication. So it means you can have some data loss, but it's a more affordable solution, which, some people say, well, I can only have 0 data loss. My answer is, sure, we can do that. Here's the price. And suddenly people go, you know what, some data loss isn't bad, especially when the price is a lot cheaper. And there's minimal impact on asynchronous replication. And one of the cool things that I heard Ned Pyle talk about, and Ned Pyle is the senior PM for storage replica in Microsoft, he talked about how there are scenarios where storage replica actually improves storage performance. So where people have had HDD-based SANs and they install a couple of SSDs into their storage system to provide journaling, or basically it's write caching for storage replica. Suddenly they find that their writes are improving in performance because they're using SSD to commit the transaction, which then gets committed to the HDD and replicated. So you get some interesting performance boosts there potentially. If you have a lot of data to get from site A to site B, you can actually see it. So you copy your data onto a disk, you bring the disk to the second location, you copy it onto the storage system in the second location, you implement storage replica, and it basically fixes up the differences, which is great. Now, how do you get your data onto that first disk? If you have a lot of data, that could take a long time, especially those large collections of small files, because a lot of that copy operation, the time that's taken, is taken to deal with metadata. So you could use a tool like Robocopy, cool, but it's going to get slowed down by all that metadata. Storage replica actually has an interesting solution, where you can replicate from a local volume to another local volume on the same server. So you could replicate from a LUN on your SAN that's mapped to your server to a disk that's connected to your server. And then take that disk, bring it to your location, copy it onto the SAN in the second location, and away you go. Minimum amount of downtime. And because it's operating way down low in the system, it doesn't really care as much about the metadata because it's dealing with blocks. So it's going to be much faster than Robocopy. The networking that's used by storage replica is SMB 3.11, so that's the version of SMB that we have in Windows Server 2016, which means we have easier firewall management, and we know SMB 3.11 is very resilient. The protocol has been very tough. It's, I believe, has had either no found bugs or very few found bugs. And most of the issues we've seen in networking in 2012 and 2012 R2 have actually been in third-party drivers and firmware. It leverages or can leverage SMB Direct, which means we can do remote direct memory access, or RDMA. That's low latency, low CPU impact, high performance networking, which you get in iWarp, Roki V2, or InfiniBand. And you can do long distance networking with these things because Roki V2 is routable Roki, and InfiniBand with MetroX from Mellanox can actually span distances, like I said earlier, of up to 80 kilometers, depending on the models you go with. One of the cool things we can do here is we can control what NICs on our servers are used for replication, and we can actually do this down to the volume level. So if you have 10 NICs or 10 networks and 10 volumes, you can say these 10 volumes are replicated on 10 different NICs. I think that's a bit crazy. What you're probably going to do is maybe say, you know, I'm going to replicate all my volumes over this particular NIC or network because it has no impact on my other production systems or my cluster systems, or maybe there's a particularly high IOPS volume that you want to give a dedicated network to. Now let's talk about one of the features of 2016 that I think is going to get a lot of attention and may even drive a lot of people to deploying 2016, which is Storage Spaces Direct, or S2D. Storage Spaces Direct is a whole new way of doing storage. And what I want to do is just explain how it's put together so you have an understanding of what we're talking about. We're dealing with storage that is inside of servers. We're not talking about JBODs, we're not talking about SANs or NASs or any of that stuff. We have a bunch of servers, a minimum of 3, preferably 4 or more, that have disks inside of them. Those disks can be SAS or SATA. SATA means lower cost, and we can and Storage Spaces Direct sits a virtual SAS layer on top of that, so it's dealing with some of the problems of SATA, or virtualizing away the problems of SATA. The disks can be HDD or SSD. HDD is great for capacity, so you get those 4 terabyte, 8 terabyte, 10 terabyte disks. We can have SSD, which can give us a layer of performance in front of those 7200 RPM HDDs. So we can get maybe 50,000, 60,000 IOPS from an SSD. And we can have NVMe flash storage. That's basically flash storage that sits on a PCIe bus running at 420,000 or more IOPS. That's a crazy number, 420,000 IOPS. Some people don't get that on a SAN, let alone from a single disk. What do we require for production? Well, networking-wise, we need 10 gigabits per second networking, preferably 2 NICs, but we can do it with 1. And we need RDMA for SMB Direct, because we need low latency, low CPU impact networking. We cluster the nodes. So we're aggregating the compute capacity of these nodes. We're going to treat them as a single unit, a cluster. That cluster can be a minimum of 3, preferably 4 though, and we'll talk more about that later. And it could be a maximum of 16 nodes in a cluster. So in Technical Preview 5, that is 16 nodes. That might get increased. I don't know. I don't have any insider information on that. But when you think about 16 nodes, possibly, you know, with 24 disks in them each, that's a lot of capacity that you could be talking about there. We get high availability from this, and we can leverage cluster shared volumes, or CSVFS, because we're dealing with a cluster, which means we're talking about single volumes that span the cluster. We use storage spaces and we aggregate the disks. So now we're aggregating all of the capacity, the performance of those disks, and we're getting fault tolerance. So storage spaces can give us fault tolerance. We'll talk a little bit more about that. Then we run enable cluster storage spaces direct. That's a pretty obviously named PowerShell commandlet. And that commandlet wraps up a lot of functionality. It simplifies the deployment of storage spaces direct clusters. It'll analyze the disks, and it'll identify what disks are going to be used for caching, tiering, and for capacity. And I'm going to talk a little bit more about those concepts later on. From that pool, we now create LUNs, or virtual disks. So in storage spaces, a LUN is referred to as a virtual disk. Basically, a virtual disk takes slices of each physical disk in the pool, meaning we have the performance potential of all of those disks, and we're able to aggregate the performance potential of all of those disks. We format that virtual disk with Resilient File System, or EFS. We are not going to use NTFS. Or EFS has a lot of functionality in there. One of the cool things in 2016 is the optimized operations for VHDX. It's also metadata based, so a lot of operations like expanding virtual hard disks, whether they're fixed or dynamic, basically become metadata operations. A file system is told, hey, don't worry about doing stuff, that's just zeros. You don't have to actually go out and write zeros, because trust us, it's just zeros. And when someone comes to read it, it's just zeros. So it's saving us a lot of time. That volume is then added as a cluster shared volume in the cluster. and we start using the cluster shared volumes in the cluster for whatever it is we want to do. So maybe we're using this cluster as a scale-out file server, and we're sharing that capacity out using SMB3 shares. So that's one of the first two purposes of this cluster. We're using it as a new way of doing scale-out file server. So not worrying about JBODs and SAS layer or any of that stuff. And this is actually what people thought scale-out file server was when Microsoft announced it in 2012. People weren't thinking about shared JBODs or any of that stuff. They thought it was internal disks that were going to be replicated between nodes in a cluster. This is what we get now with S2D. And it is a SAN alternative. The performance of this stuff is just nuts. We're seeing numbers like 4 million 4K random IOPS coming out of modest clusters that have a mixture of NVMe, SSD, and HDD disks using high-speed networking from the likes of Mellanox. It's very interesting stuff. And has the potential of simplifying and speeding up and reducing the costs, especially if you're using SATA disks of a storage system. But another possible usage of it is hyper-converged infrastructure. So we've all heard of the SimpliVities and the Nutanixes of the world who will give you a server for $65,000. Well, now you can just go to your typical server vendor and say, can I have a server with some fancy disk in it and some 10 gig networking, and it sure ain't going to cost $65,000. And that thing is going to be fast because it is designed for Hyper-V. And what we're doing is we're flattening the infrastructure, having a bunch of servers or systems that do storage and another bunch of servers and systems that do compute or Hyper-V. It's everything. Each node is doing compute and storage. And no, there is no SMB3 networking going on. We're not storing virtual machines on file shares. We're simply storing the virtual machines on the CSVs. People often think, oh, there's no loopback of SMB3 allowed. There's no SMB3 here. Now, there is between the nodes for data transport, but you're not storing virtual machines on SMB3 shares. The final result is we get a Lego block infrastructure. I put in a cluster with 4 nodes, and I need more capacity, whether it's compute, RAM, storage. Great. I just drop in another node, add it to the cluster. The storage system will even itself out, and I now have more capacity. And that's going to be very interesting. I think a lot of people are going to deploy 2016 because of this, because now they can do HCI at a cost that is affordable and even leverage things like RDMA networking, whether it's Roku V2 or InfiniBand or whatever, at a cost that they can swallow. There is resiliency in this thing. So we do get disk fault tolerance. Storage spaces allows you to define disk fault tolerance at the LUN level. So each virtual disk has its own levels of fault tolerance. We typically, well, I'll talk about that a little later on. We also have server fault tolerance. So we can lose up to 2 nodes in a cluster if we are dealing with storage spaces direct. We get a rack fault tolerance. We can define fault domains and spread our S2D node cluster node, or our S2D cluster nodes across different racks. So if one rack has a local problem, cluster stays operational, our data stays operational, our virtual machines stay operational. Sounds a little like Azure to me. We also have disaster recovery capabilities. So we can have an S2D cluster in one site and another S2D cluster in another site. We can replicate virtual machines using Hyper-V Replica. Maybe we use Azure Site Recovery, so we replicate virtual machines to Azure. Or, you know what you can do? You can turn on Storage Replica and replicate your virtual machines using that. So let's start talking about some of the disk mechanics stuff. Storage Space Direct, or S2D, does support 3 different types of disk. It supports HDD, SSD, and NVMe, or SAS bus. When you enable Storage Spaces Direct, the fastest disks in each node are going to be configured as caching devices. This is a persistent read-write cache device. So it's a disk that's being used to cache reads and writes. The remaining disks that are found in each server are going to be used as capacity devices. So this is where our data is going to live. And these are the devices that we're going to create virtual disks from. These are the guys that are going to have the fault tolerance and all that stuff. And these are our LUNs that we're going to format and use as CSVs. We have a feature called multi-resilient tiering. So from those capacity disks, when we create a virtual disk from that capacity or from those capacity disks. We can define levels of fault tolerance. In the past, we've had two choices. We could do mirroring or parity, and there were sub-choices within those two categories. Mirroring was great because we got great performance, but the downside of mirroring, kind of like RAID 10, is that you lose at least 50% of your capacity. In Storage Spaces Direct, we want to actually do three-way mirroring if we have 4 or more nodes. That means we actually lose 66% of our capacity with three-way mirroring. If we have 3 nodes, we can do two-way mirroring, so we lose 50% of our capacity. That sounds like we're losing a lot of disk. So what Microsoft did is they gave us this multi-resilient tiering model where we can have mixed levels of fault tolerance within a LUN. So we can have a certain number of devices used for three-way mirroring and another set of capacity devices used for parity or erasure coding, which is much more efficient at storage capacity. So what we get happening when we do a write is a write goes to the cache device, and then it's flushed down to the mirrored capacity. Eventually the mirrored capacity fills up, and the older blocks are pushed from the mirror capacity down to the parity capacity, where they sit and are accessed less frequently. If there's a modification to blocks in the parity capacity, the modification comes through the cache, hits the three-way mirror, and REFS does very efficient metadata operations to update the relevant blocks in the parity capacity. So we're really getting a mixture of a lot of things going on. We're getting extreme speed from the caching devices. We're getting almost extreme speed from the SSD disks that are sitting in the capacity tier, so we're getting tiered storage at that level too. Plus we're getting tiered performance in terms of our resiliency levels. So we're getting mirroring to give us high speed access for our active data, and parity to give us efficient access and with fault tolerance for our colder data. So this is very interesting. I don't think I've ever seen anything like this before. It blew my mind the first time I saw it. I was like, okay, this is like 3D performance tiering and fault tolerance. It really warped my fragile little mind, to be quite honest, and still does. Speaking of Storage Spaces Direct and Storage Spaces, you probably want hardware to run that on. And funnily enough, MicroWarehouse, who are running this webinar, distribute Storage Spaces hardware made by Data On. So if you're interested in a solution like a 2-node cluster for a small medium business or a branch office, we've got cluster-in-a-box solutions that Data On just updated recently, where they added in a pair of Mellanox RDMA-capable NICs into each blade, so you can sell that stuff. If you want to do the traditional scale-out file server with huge capacities of disk, you can do that using JBODs. So they've got JBODs put up to 70 disks each, and you can put 4 of those behind 4 servers, giving you petabytes of capacity in 16 U's. And coming soon, in fact, launching next week at the Ignite conference, Data On will be talking about their 1U and 2U Storage Spaces Direct servers, which will leverage Mellanox networking, NVMe, SSD flash, and affordable HDD capacity, doing that multi-resilient tiering. And they recently did a demo at an Intel event, hitting 2.4 million IOPS. So this is some very cool stuff you'll be able to do very soon, thanks to Data On. And if you're in the European Union and you would like to buy some Data On, if you're a Microsoft partner, you can contact MicroWarehouse at www.mwh.ie. If you're not a Microsoft partner, you're a customer, talk to your reseller, get them to contact us, and we'll give you pricing on that stuff. Okay, so we have deployed 2016, we've got clustering, we've got storage, replica, we've got Storage Spaces Direct. How do we troubleshoot that stuff? Well, the old solution is you go to Event Viewer, you gather up lots of logs from there, you go to the various different tools, run PowerShell commands for the various different tools, and gather up lots of logs from lots of different servers, and then send that off. Or you try to troubleshoot it yourself and have to bounce from one log to another from different servers. A lot of time, a lot of effort, very, very difficult to troubleshoot. 2016, we get one command out, get storage diagnostic info, which will gather all that data together and create 2 logs for you, both of which are chronologically ordered. So you'll get an event log of all the events from all the servers, from all the services on those servers in chronological order, so you can start evaluating what happened. And also get an ETL log, which is also chronologically ordered, which Microsoft can use to do deep debugging. So that makes life a lot easier. Like I said, Microsoft want to make owning this stuff and administrating this stuff much easier for you guys. So that's the end of all the technical stuff. There's a few things I want to share with you. So MicroWarehouse, we do a lot of events, we do a lot of webinars and stuff like that. The big one we're planning right now is we are going to be doing the Irish launch of Windows Server 2016. So Microsoft aren't doing it locally, so we thought, you know what, let's do a community launch. And we're getting some MVPs from around Europe to present at this. So if you're in the Hyper-V or clustering world, you may have heard of Didier Van Hooy from Belgium, aka Working Hard in IT, or Carsten Rackvel, who's also known as Hyper-V Server. Damien Flynn, big system-centric guy, and Azure Stack guy, and Kevin Green, big system-centric guy, a guy who does a lot of stuff in OMS in Azure. We're going to have these guys all coming into Dublin. I'll do a little presenting as well. We'll have a big keynote and 2 breakout tracks covering on-prem, so Windows Server stuff, Azure Stack stuff, and we'll also have a cloud track, so if you want to learn some Azure stuff. That'll all be on October 26th, starting at 10 a.m. in the middle of Dublin City. So if you in the Marker Hotel, which is a very lovely hotel, walking distance to lots of cool locations like the Guinness Storehouse and Jameson Distillery and historic O'Connell Street and Trinity College with lots of ancient books and stuff that you can't read but you can look at through a glass wall. So lots of cool things you can do, or you can go on some of the, what's the name of that green bus, the Paddy Tour or something. You basically get on a bus and get drunk for the day and go see some scenic locations through beer glasses. So yeah, very typically Irish. So a lot of cool things there to watch out for, and free attendance. So if you can find your way into Dublin, well worth checking out. We are also launching our new Azure training courses. So the first one that that I've spent the last 4 weeks writing is an Azure IaaS virtual machines hands-on training course. So if you want to start from scratch about learning how to use Azure virtual machines, storage and networking in an ARM or CSP environment, then we've got it all. Storage, networking, peering, site-to-site VPN, VNet to VNet VPN, DMZ design and deployment, user-defined routing, virtual machine deployment, JSON deployment, PowerShell, backup, load balancing, geofault tolerance or traffic manager. It's a 3-day course. A lot of hands-on. So yeah, I do lecture for a little bit on the first day, but then there's lots of hands-on afterwards. So you can contact events@mwh.ie for details on costs. I will tell you, it's low cost. We are not talking about 2,000 euros here. We are definitely not talking about that. So, and this is up-to-date training. So it literally, I finished writing it on Friday of last week. Including some of the new Azure AD management stuff that's in there. So I will continue to update that course as things change. So you can contact events@mwh.ie for cost details and for registration details. So thank you for tuning in. We have managed to finish this one in 50 minutes. I don't know if we have any questions, do we, John? We have one question. Let me get my mouse working again and see if I can actually get this to pop out. So Narayan's asking, Windows Server 2016 failover clustering, do we have site awareness feature for virtual machine as well, or adjusted for nodes? So the aware of the sites, which means that they place virtual machines accordingly. If yes, do we have a new option, or is it still possible owner CSV ownership? Is this in the GUI or is it still in PowerShell? CSV ownership is actually in the GUI, always has been, and you can move CSV ownership around in the GUI as well. You can also do it in PowerShell if you want. And when you do move CSV ownership from one site to another, or if it gets failed over from one site to another, the virtual machines will actually live migrate. And bear in mind, if CSV ownership does fail over, it will try to fail over within the site if that's possible. The only time it will go to another site is when you've lost the primary site, to be quite honest. But virtual machines, they'll stay in their site unless the site goes offline. And if you want, if you're doing a guest cluster, so you're doing a failover cluster inside a virtual machines, you can define sites in there as well. So there's a lot of granularity that you could do with that stuff, and probably some very interesting things you can find out with nested virtualization. Gotta think about that, because remember, we can do nested virtualization in Server 2016. So there's potentially some very funky things we could do with that, creating sites that don't actually physically exist. So if anyone's got any questions, fire ahead. We actually have time for them for the next few minutes before someone from Microsoft comes in here and kicks us out of the building. I haven't said anything to offend anyone on Microsoft today, have I?
No.
Not today.
No, be nice. We're in their house.
We are in their house. I need to behave. No more questions? Cool. Okay. I think what we'll do is we shall wrap up. Keep an eye on my Twitter feed or at MWH Distribution, because we will announce another webinar for next month. Learn.mwh.ie is where you'll find all details of our events, our training, whether it's local or online. It's always on there. Thanks, Didier. Yeah, we shall wrap up, and I suspect we might do something Azure-ish next month. We shall see. I think maybe we'll do some Azure Backup Server and start talking about new things that Azure Backup Server has recently released, which are very interesting, and solve some problems for small, medium businesses or bandwidth-challenged businesses. So thanks everyone for tuning in. Really appreciate you taking the time in the middle of a workday or during your lunch break. And we shall talk to you next month. Have a great rest of the day. Bye.